Hello everyone, welcome to our machine learning session. In the previous class, we have seen how you are going to prepare the data, what kind of linear regression and multiple things we have learned and how it is going to impact the model which we will be creating. So getting started with it, in the previous segment, we have created our Excel sheet in which we have created our own data set. And we have considered certain things so that it is not going to hamper the model, the prediction model, which we will be creating. Now, understand today we are diving into one of the most crucial part of machine learning, and that is called data preparation. Whether you are building models using scikit-learn or pandas, what you do before modeling determines how well your model performs. Let's learn how you are going to do it in the right way. So the first part which you are going to do, imagine cooking with ingredients that are expired, dirty, or missing. The dish won't turn out great, right? Have you tried it? No, we usually throw it into the dustbin, right? Similarly, raw data, which you are going to get on different sources or whatever is being provided to you, that is completely raw. That raw data often has missing values, noise, or inconsistency. Data or you can say data preparation is like cleaning and organizing your ingredients before cooking. This improves the model accuracy and how well it performs on unseen data. Basically, raw data, you cannot directly get started with your coding and you are going to, work. You have to include structuring it, you have to scale it, you have to encode it, and then later on you are going to split it. You needed to find out whether there is any null value, and I'm going to show you how you are going to find that using pandas. So let's understand that aspect. Now, how you are going to structure the data. We need to organize our data properly. Each row represents a sample and each column is a feature. We separate features by considering it as X from the target variable that is considered as Y. Think of pandas as your assistant chef. All right. It helps us inspect, clean, and manipulate data easily by using certain libraries. To organize data in tabular format, like rows, you are going to take samples, and columns you are going to consider as features. You are going to separate input features as well as you are going to target variable you are going to keep as Y. Use pandas for inspect, cleanup, and basic manipulation, and that is what you are going to run. And we are going to do that step by step in our code. All right. Now, how you are going to handle the missing data? Not all data is perfect. Some entries might be missing. We can either drop these rows or fill in the missing values using techniques like mean or median, or you are going to use tools like simple, you can say Simplometer or simple amputer uh, from scikit-learn library, which is going to help you do this task smartly. So basically, when you are going to run advanced imputation strategies, in that what you are going to do, you are going to fill mean or median or real final stages in it. That is how you are going to handle the missing data inside. Now let's understand how you are going to do feature scaling. Some ML models care a lot about size of the number, especially algorithms like KNN or SVM, which is scalar vector model. That's where scaling comes in. We can either standardize the data, or we have to normalize it to bring all features to a similar range. Scikit-learn is the tool, and it has a tool like standard scaler and min-max scaler for this particular task, which you are going to use to normalize all values from 0 and 1 using min-max scaler. And this is called feature scaling, which we are going to do in our models, which are upcoming. When you are going to get started, you are going to put your hands on on the models or prediction models which we are going to create. Moving to the next one, that is called encoding categorical variables. Machines don't understand text like red, blue, high, or medium. We need to convert these into numbers. For example, one hot encoder is great for categories with no order, or label encoder or ordinal encoder is useful when categories have an order, maybe structured, or there is an order which you can see, or you can find certain patterns in it. So these are encoding categorical variables. So these like label encoder or ordinal encoder or ordinal data, these must have an order, and with order you can perform with these categorical variable functions. Now, other when you are going to talk about one hot encoder that works only without any order. So this is what we will be learning when we are talking about encoding categorical variable. Now, moving to the next one, we are going to now talk about feature transformation. Sometimes our data is not linear. And when we are saying it's not linear or it is a sequence, we can use transformation like log or power to fix this. If we think relationships are not linear, tools like polynomial features can help. These techniques can help our model understand data better. And these are all things, all these features, all these methods which we have mentioned over here, these are going to help you to make your data structured without any null values so that you are going to minimize the loss function and greater accuracy results you will be getting from the model which you will be creating. So make sure that you are going to take care of each and every factor which is being mentioned. Now, splitting data sets. Split data set into test and train. Let's understand this. Before training, we split our data into training and testing, and sometimes validation sets. This helps us test how our model performs on unseen data. Tools like train, test, split in scikit-learn, which you will be using in the model and the data set which you have just defined. So this income prediction model, we are going to use scikit-learn train test split to train the model and to convert the testing model and to evaluate that function. It learns very easily by using model fit command, and it makes it very easily for the classification task. Moving to the next one, here you are going to understand a very common question, that is how much data should go into training, testing, and validation. A good rule which you are going to understand, that is 60-70% training, 10-20% validation, and 20 to 30 is testing. Not more than that. And don't forget to shuffle your data before. And that you are going to do by using random sampling. Ensure that this rule is going to be carried forward before splitting. You have to keep it unbiased. Otherwise, that shuffling and the random sampling will keep on happening. And I'm going to show you how you are going to use that random state in the code, which we will be doing in the next class. Moving to the next one, here we are going to understand what is data imbalance problem. Sometimes we have more of one class than others. Say 90% healthy and 10% sick. That happens in every class. Whenever we are visiting, we are sitting everywhere, wherever you are going to go. Whether you are working in office, you are in the school, you might find this kind of ratio. That's a data imbalance. If we don't address it, our model might always predict the majority of the class, right? Ignoring the minority. We check this with value counts in pandas, and that is what it is going to help. Pandas plays a very, very important role, as I have already mentioned. Consider Panda as like your formulas in Excel, which performs your task rather doing manual things. It converts into the formulas, and you can use direct libraries to run your computations. Now, moving to the next one, here we are going to see how pre-processing imbalanced data. To fix imbalance, we can either add more of the minority class, means oversampling, or remove some of the majority class, that is called undersampling. Also use matrices like F1 score as well as ROU AUC instead of just accuracy. And some modeling allows using class weight is equals to, and that is what you are going to call as balanced. Basically, when you are working with deep learning models, here you are going to look to values that is called weight and biases, and how you are going to get a balanced approach there. Let's see what you are going to learn by using pandas for pre-processing. Pandas is like our data cleaning toolkit. It helps us explore filters and transform our data by using functions like head.info, describe, that gives us a quick snapshot where, or you can say, while your fill now or group by helps clean and prepare the data. It is going to group by all the majorities and minority, and fill now is going to tell you what you are going to fill all the null values with. These are all how you are going to handle the null values and encode categorical values, as well as filter groups and transform features. You are going to load and explore data by putting them into data frame like data frame.head, data frame.info, and data frame.describe. So these are all features which are pandas methods which you will be using for pre-processing your data. Now let's understand how scikit-learn tools are going to help you considering all these factors. So first of all, scikit-learn comes with a full set of tools for pre-processing, splitting, and even evaluating models. It's powerful and flexible whether you need scaling, encoding, or building a model or predictive pipeline. Scikit-learn has all these covered itself. Pipelines to automated data transformation or modeling. Each and everything is absolutely included in it. When you are creating any model for test, train, split, you are going to see how your testing data and what exactly is going to be your loss function, or how it is going to calculate the accuracy on behalf of confusion metric. So each and every part you will understand. Right now, I'm just explaining all the key features and terminologies in front of you. Basically, you are going to understand it more when you are going to put your hands on practice by putting the data set, and you are going to get started with it. Before you get started with the data, make sure that you are going to keep your system ready with that. First of all, what you are going to do, you are going to download Python. Second part, which you are going to do to get started with machine learning model, there are certain libraries which you are going to add by using your command terminal or by opening the terminal. So you are going to write pip install scikit-learn, pip install pandas, pip install numpy, pip install maths, as well as pip install seaborn, pip install tensorflow. These are all libraries. And however, no need to worry, I'm going to show each and every step in front of you. Now let's see what pipelines for data preparation is all about. So pipeline for data preparation is like why do things manually, right? We usually have like certain things which we try to do manually. Even nowadays, when you are going to write code manually, that is also gone from your end. As of now, AI is well versed to write codes for you. Only fundamental information that you needed to know where and how your data is going to get processed, which classification you are going to put. And you can put that only if you understand your data very well. So when we can automate them, pipeline helps us combine all the pre-processing steps into one neat flow. This reduces the code, avoid mistakes, and improve productivity, or you can say use this particular data or pipeline for column transformation from sklearn for this. And sklearn is nothing, it's scikit-learn. In short form, when you are writing it or when you are saying that, you can call it a scalar. Moving to the next one, to understand how, like what sort of best practices you can opt for when you are preparing your data. That is, before applying any transformation, know your data well. So in the previous segment, we have created our data. Why am I emphasizes more upon to create the data? Because when you are creating your own data, first of all, you understand it well. You know what pattern it follows. If we are increasing the years of experience, definitely it is going to increase, like it is going to impact the salary also of that particular person. So there is a correlation, or you can say there is a dependency. That's why I focused more on creating the data. Because when you are going to take any data set, either from GitHub or any sample data, first of all, you needed to clean the data. And cleaning data is going to take a lot of time. For that, you needed to be well versed with Pandas library. And as of now, the classes which we are doing, that is completely based on machine learning, where Pandas is being used as a tool. We are going to use Pandas only to fetch the data, to read the data. And if it is required somewhere to use as group by function, that is what we will be doing. So before applying any transformation, know your data well. That is first key. Always visualize it, use the right transformation, and avoid data leakage by using proper pipelines. And always evaluate your model and multiple matrices. Like multiple matrices means when you are going to apply mean, absolute, error, that those are all matrices using mathematics. So you are going to find what exactly is the difference between actual and the predicted value. When you are going to find the discrepancy in that, then you are going to calculate what is the error percentage in it. If the error percentage is huge, it means the patterns which you are going to follow, you needed to look onto it. It means the pattern has certain discrepancies, or you can re-refine your data. Matrices are going to help you to provide you an insight where your data is lacking, whether it requires certain things in it or not. So these are all things which you are going to keep, you are going to take care when you are preparing your data. The last and the most important step, those are final thoughts. Data preparation often takes 70% of your time in machine learning, but it's totally worth it. First step, which you are going to understand, that when you are working with your data and you are preparing your data, you are spending time with it. You are running your own analogy. You know each and everything. First of all, that analysis is happening in your brain. Now you know what is the end result which you wanted to take from the data. And you want to know what is input, what input you are going to give, the processing, which processing is going to happen, means the classification, the mathematics behind machine learning, that is going to happen, and what is going to be the output result, or means your output. So that should be clear. And remember, use Pandas for handling the data and scikit-learn for processing and modeling. Good data leads to great models, and that's why this preparation, data preparation, is needed. And you are going to use all these segments which we have discussed preparing your data. Now, preparation of the data includes one more thing, that how you are going to create data using your Python library or NumPy. So you can create data by putting in the code as well. So in this machine learning entire module, I'm going to show you different ways. First of all, we have created the data. Second segment, somewhere I'm going to show you how you are going to take a sample data from outside. And don't worry, I'm going to take a supervised data, which is going to be clean, so that you are not going to run around and put certain libraries in it. We are going to majorly focus upon machine learning model and how it works. The third part, which I'm going to show you, how you are going to create your own data set by using NumPy. You are going to create like simple putting rows and columns into consideration. Randomly, you are going to create, and then we are going to run our analysis in it. So let's see how the data looks like. We are going to go back to our data sheet and we are going to see how our data is. and what inferences we are going to take from that. So everyone, here is the data which we created in the previous class. So here we have kept years of experience and salary. So these are the key factors which we have included in approximately 39 rows we have taken over here. Now, it's that easy that you can do this segment and the visualization part inside Excel only. So what you needed to do by putting Control A, or just put Control A like this, so that both the columns are going to be selected. And what you are going to do, you are going to click on this Analyze Data. This Analyze Data is going to create a graph in front of you so that you can actually see the visualization. Now, the same visualization you are going to get when you are going to create a chart by using Matplotlib library. So exactly this you will be getting. So I'm going to do that. Now, why I'm showing this in front of you? Because the data is very small. So if you get any data which is small and you were asked to create a machine learning model or prediction model on that, so the first thing which you are going to do, you can calculate, you can see the pattern by just not going through the entire data, because when you are going to go individually, one column, two column, three column, four column, so it takes time. So what you can do, you can select the entire data and you can just go analyze data, and it is going to, with the help of AI, it creates analysis in front of you. Now you can see the trend over here. This is how the salary looks like, and this is years of experience. And here is the trend which is like going on in a straight line. It's like it's exactly a straight line which you see. It means I needed to make some changes in the data. Entirely like straight line you can see over here. So if even if I'm going to extend it right to 50 years, it is going to just make the same thing, right? So this is how you are going to create in case like if you don't want to go, because when you are going to write the code, it is going to obviously take time. So the first hand analysis you can do if the data is small and you know what, how, and what you are going to do with that. So simply what you are going to do, you are going to select the entire data and you are going to run the analysis and see the trends over here. See the patterns over here. And not just one chart, there are multiple charts. If you want, you can see this chart also. So I'm going to click onto it, and at the bottom, you are going to just like keep it sidewise. So over here also you can see certain trends, right? So salary in thousands, and these are number of years. And over here you can see 1.5. So whatever we have mentioned over here, whether 3.3, you'll be able to see each and every part as a straight line over here. So even if I'm going to add 12, let's say, let me check with 15. 15 is going to get 150000. So likewise, and now I'm going to see, I'm going to refresh basically. I'm going to select once again, Control A, and now I'm going to analyze. I'm going to just take this part, delete and delete. And now I'm going to insert this chart. Now, can you see how it has created a straight line, a dotted straight line? This dotted straight line means it is going to consider all the values. If I'm going to consider this 12, and 1,20,000 is going to be the salary of a person who is 12 years, who has 12 years of experience, and the person who has 14 years of experience will get 1,40,000. And therefore, a person who has 15 years, which is in between 14 and 16, you can clearly see that it is in the middle of this box and it is going to get 1,50,000. So this is how it creates a straight line, because the data is trained itself. And similar pattern, once you have analyzed the pattern, the similar pattern you are going to get when you are going to run the code. So this is the visualization which you are going to get. So we are going to hope that you will understand this, you are going to practice it, and we are going to see some more facts in the coding segment also. So let's quickly revise what we have done in this particular session. In today's session, we have understood how you are going to prepare your data before you are going to use the data into your machine by for creating machine learning models. So to clean the data, there are certain scikit-learn libraries as well as pandas library, which you are going to use to clean the data. If there are any null values, if you wanted to fill and group by these, how the data looks like, whether it follows any pattern or not. So these are all considered as preparing your data before you create and consider that for model prediction or model creation. So this was all about today's session. I hope you have taken a lot from today's session and you are enjoying the session. In case if you have any doubt, any query, please feel free to share. Thank you, everyone. Stay tuned and keep learning.